Good morning, students. Today I thought we'd go through a little bit of data binding, but not in the traditional sense. What we're going to actually do today is build all the functionality of data binding manually. So we're going to build the whole thing from the ground up using C# as a way of really exploring what data binding is and how it works. And this can be useful both for that building that understanding and occasionally because we'll want to do things with our controls that really aren't supported by the built-in data binding. So understanding how we can spoof that for our own needs will make us much better WPF programmers. So to start, I have a starter project that is a note-taking application, so a very kind of simple application that we're going to be filling out and adding this data binding to. So you can clone the starter code from GitHub, and then we can dig into this together. So the very first file I want to take a look at is our note file. This is our data file, so this is what represents notes in our note-taking app. If you look, you'll notice it is in the note manual data binding data namespace, and we have it in a folder over here reflecting that namespace. So whenever we pull this into another file in another namespace, we need to make sure that we add that using statement. Now the note itself really is fairly simple. We have two properties. A title property has both a getter and a setter. It's of type string, and by default we're setting it to the current date and time. The body property also has a string, and it starts as an empty string, has both the getter and setter. And notice we're using the auto implementation of properties. So we just say that it needs a getter and a setter, and we're not creating a private backing variable at this point. Now let's take a look at our note editor XAML. This is pretty straightforward. We have two text boxes, one at the top for the title, one in the lower part for the body. We've set those up just using two rows in a grid where one row is 10 times the size of the other one. So the title is the smaller one, and the larger one is the body, and we do just a little bit of formatting with the text to center it and make it 30 pixels tall. So that is our note editor, and notice we've also put that into the UI namespace. Now we're ready to take a look at our main window, XAML, which is just containing the note editor plus these three buttons across the bottom. Those are for making changes to the data object so we can see if our binding is actually working. So we have three of those. One creates a new note, one mutates the existing note, and one clears the note. So the first thing we need to do is take this note class and make it available for ourselves in the note editor. So in order to do that, this note editor needs to have a way of holding that particular instance of our note. So what we're going to do is we're just going to add a public property to represent our note. So it is a type note. Go ahead and call it note, and I'm just going to go ahead and use the auto implementation property. So a getter and a setter, and we can add a little note to the top saying that the note that will be edited by this control. And that is our note that we need to add, and where we need to add it, probably the place that makes the most sense is in this main window that holds this control, because it also has these three buttons that we want to be able to edit that note object. So we're going to get into the code behind for that main window. And we'll go ahead and create a note here. And notice we don't have the namespace, so it doesn't know about the note. So let's go ahead and add our namespace. So this is manual data binding dot data is where the note is located. And now we can create a note instance. And this is basically going to be a private variable of type note. And we'll go ahead and create it. So we'll create a new note to fill that. And maybe just a little quick note on the top. And then after we have initialized our component, we will have access to that editor, which, if we take a quick look, we gave it a name of, oops, the main Windows YAML. Notice we gave it a name of editor, so we'll want to use the editor property here, which corresponds to that name, and then we can say its note is going to be this note we just created. Now it is important that we do this step after we initialize the component. Remember, initialize component is what actually takes the XAML and applies it to our class. So if we try to do this before the initialize component, the editor will not exist. So we definitely need to do that in the right order. While we're here, let's go ahead and add a couple of event listeners for those 3 buttons. So our first one will be handling the new note. And we'll just write a very generic event listener. Remember, in WPF, button click events are handled with a routed event args instead of just a regular event args or a click event args. So it's a little bit different if you came from Windows Forms, but not tremendously. So in this case, we want to replace our existing note with a new note. So we'll go ahead and do that. And we need to make sure that the editor also has that exact same note. So we need to make sure that the note that we're saving in our window, lowercase note, is what we've applied to our editor. We want to keep those 2 in sync. And of course we should add a comment, like always. Okay. Our next one will be our clear note. And this one will just delete the body of the note by setting it to an empty string. And finally, we'll do one for on mutate note. And in honor of mutation, we will use a quote from Master Splinter. Feel free to replace this with anything that you would like to use. It doesn't have to be this particular quote, but I thought we'd have a little fun. And of course, before these will be used, we need to assign them to those buttons. So either in the constructor here, or we can do it directly in the XAML. If you do it in the XAML for the window, we'll just add it as a click event handler. And because these match the signature of what it's expecting, we should be able to get them in the autocomplete. If you want to do it through the constructor, then you're going to have to add a name to each of these buttons so that you have something to reference in the code behind. Alright, so that sets up our main window and creates our note and allows us to do all of those mutations. Now the next thing we need to know is when that note changes. We will be changing that note object from the main window, which means the note editor doesn't know that that's happening. we want that note editor to be notified and be able to update itself whenever that happens. We need to basically give it some kind of message saying it's time to update yourself. Now you might think from our earlier discussion of message passing that one obvious track we could take is we could add a method to the note editor code behind. So we could do something like public void on note change, and we could pass in the details about that change. In this case, maybe a string for the new title and a string for the body. And inside of that event handler, we could just say the title.text equals title, and body.text equals body. Now this approach does work. It just means that we would have to invoke this method from in our note editor, in that code behind, basically after we make each one of those changes, from our main window. So for example, we could in here say something like editor dot on note change and pass in the note dot title and the note dot body, and we'd have to repeat this step in each one of these event handlers. Now there are a couple problems with this approach. One of the big ones is clearly we're going to have to do this a lot, and the second problem is it's very brittle, which means if we change how, for example, the note stores information or how the note works, that means we're probably going to have to come into the main window and change everything here, and maybe even the note editor backend as well. So there's a lot of places that we'd have to be making changes if we're doing this. We call that brittle in software engineering. We don't really like that. We don't like things to be tightly coupled. The other aspect is that if we want to use this with some other user interface element, we'd have to hook up that user interface element the same way. We'd have to add a lot of custom code to it. So it's not really very reusable as a solution either. So we really want something that's less tightly coupled and allows us to do this kind of work the same way. And if we look at how we do message passing in C#, we already have a mechanism for that style of loosely coupled message passing, and that's the event system. So if we go back to our note class, our note editor class, we could, for example, change this to an event of some kind. So this could be an event listener, which we know should always have a sender as the first argument, at least in C#, and the second argument would be some kind of event args class instance. In this case, we'll just use the generic event args, which is the base class for all events. Now, obviously, we're not getting the title and body from method parameters anymore, but we do have, as we notice, a note class here, so we could just pull it directly out of the note that we're attached to. So the note.title and the note.body. Now, there's one more thing we have to be careful of. That is that because this is a reference type, the note is, it is possible that it may have a value of null. And if its value is null, invoking title on null and body on null, those are not properties that the null object will have. So that will throw an exception. We can avoid that by just doing a null test. So we can say if note equals, for example, null, return, which short circuits this method. It drops us out of execution. As soon as this test is true, we basically drop out and we skip these two lines so we don't cause that particular problem. Okay, now that's the event listener side. In order to hook this up and make it work, we have to also create an event handler, which is the other side of the equation. And the right place for doing that is in our note. Now, an event is defined very similarly to a property, so it can be public, private, or protected. We can use all of the regular access modifiers we're used to. The difference is it has the use of an event keyword, so this is the new piece, and then it has a type just like a field or a property does, and the type is event handler. And notice there is the generic or the regular event handler. Then we also have a generic template event handler, where in the angle brackets we can provide the specific type of event arguments we want it to return, as well as a lot of different event handlers that are defined by the various system classes. Because we're using the system namespace, we get a bunch of those as possibilities. We're just going to use the very generic one, which is partnered with an event args, a generic event args, so that takes care of that. And finally, we have to give it a name. So I'm going to call this note changed event. So this now adds an event handler to our note. And whenever our note changes, we need to invoke this event handler. So basically, when you add and attach an event listener to this event handler, then that listener is going to be notified of the changes whenever we invoke that event handler. It will actually iterate through all the attached event listeners and invoke each one of those event listeners one at a time with the parameters that we have invoked it with. Now, there's also the possibility that this could be have no event handlers attached to it, in which case its value is going to be null. So before we move too much farther, let's think about where the note actually changes. At what point does this simple note class actually change? And if you think it is here, when we set the values, you're absolutely right. We have two setters. Those are the only things that are currently changing the state of the note class. So that's really where we want to handle that change event, create it and send it off. Now, that's a little problematic because as an auto implemented property, we don't actually have a body for the set method that we can manipulate. So that means we can't use those auto implemented properties anymore. We're going to have to actually implement them with a private backing variable. So we'll go ahead and add our private backing variable. It's going to be the same type as our title, so string. And we'll use lowercase title for the name. We're going to move our initialization to the private backing variable. And then we're going to modify our getter and our setter so that those will now be returning that private backing variable and setting that private backing variable. So normally we would just say title equals value, and that would go ahead and set our private backing variable. But now we're going to have to also invoke our event handler. So note changed, and to invoke it we say period invoke, and then the object that's sending the event. So it's this particular note that's changing this instance of note. So we're going to use the this keyword, and then an event args object, which we'll just create one right here on the fly to fill that role. Now, I said earlier this note changed can be null if we don't have any event handlers attached to it. And null obviously does not have an invoke method. So we need to do a null check to help protect us from that. And that could be done this way if note changed does not equal null. And then go ahead and put a body around that. However, Visual C# version 6, I believe it was, introduced a new syntax that basically does the same thing. It's this question mark before the period. And that basically evaluates note changed, sees if it's true a null value. If it is, it stops right there. It doesn't process anything after the question mark. And the note changed actually evaluates to null. Now, if note changed is not null, it will go ahead and do everything after that question mark normally. So in this case, invoke that event argument. There's one more thing we really want to do here, and we're going to add an if test. And basically what we're going to do here is check to make sure that the title that is actually being changed. So we're going to check the current value of title and check that that is not equal to the value, or actually let's check that it is equal. So if this title is equal to the value, we're going to return. That's going to stop execution early. We're going to drop out of our setter without ever invoking these two lines. So why might we want to do that? Well, it's a little optimization step because there is going to be some processing involved in doing this, where we're telling potentially a lot of user interface elements, hey, update yourself. Our value has changed. But in truth, our value is the same value if this is true. So we basically set the value of the title to what it already was, which means those user interface elements really don't need to change. So we want to short circuit in that case and drop out of execution. We need to do the same thing with our body. So we'll create a private backing variable for that. And we'll go ahead and move our initialization up there. And actually our getters and setters are pretty much identical, so we'll just tweak that. And there is our revised note class. So now whenever the title changes, we are invoking this note changed event. And whenever our body changes, we are invoking this note changed event. Now that we have our event handler, we need to attach the event listener that we wrote in our note editor to that event handler. So we're going to jump back to the note editor backend code. And now the question is, where should we actually attach this event handler? At what point do we need to attach the event handler? Do we need to do it when the note's created? Well, no, because at that point we don't actually have a note. Remember, its default is null. And definitely we're not going to do it inside the event listener. The real place we want to do it is here, again in the setter, because whenever we add a new note or change the note of the note editor, that's when we're going to need to attach that event listener, because this is a new note. So again, we can't use auto properties anymore. We're going to have to create a private backing variable. And our getter is pretty straightforward. And our setter is where things get interesting. So in our setter, we want to, of course, set the note equal to the value. But before we do that, or after we do that, we want to go ahead and attach that event listener. So the note changed event handler, we're going to attach our on note change event listener. So now when the note says, hey, I'm changing, we're going to trigger this code and we're going to go ahead and do that. Now, just like before, there is a possibility, because this is a reference type, this note, that its value is null. If we try to attach or reference the note changed event handler on null, null does not have one. So we need to go ahead and do a null check. Make sure that that's not the case. If it is null, if we're setting it to null, there's no reason to attach the event listener, because there's going to be no events to listen for. Now, once we've attached that event listener, that is a reference tied into that object, and if we get rid of that object, so if we remove that from this note editor, we'll actually want to remove that event listener. If we don't, we'll cause what's called a memory leak, because the garbage collector will look at that note class and say, oh, somebody's still listening for your events, I don't want to collect you yet, and that note will just reside in memory where we can't touch it or use it because we're no longer doing anything with it, and that can be very problematic, because that memory just never gets reclaimed, and every time we create it and swap out our note, we're adding another note object that will never be reclaimed. Eventually we will run out of memory. So that's what's called a memory leak. It's a very subtle bug, because it takes a long time for it to actually cause problems, but eventually what it will do is it will lock up your program, because there will be no more memory available. You'll get something like a Stack Overflow exception, and your program will crash. So what we want to do is, before we change the note, we want to check to see if we have an old note already attached, which means that our old note value is not null. And if that's the case, we want to actually remove the event listener, the on-changed event listener. And that way it is no longer referencing that event handler, and that helps protect us. Now, this event listener, as we have it written right here, what it's actually doing is it's looking for future changes. So when the note changes at some point in the future, that doesn't capture the fact that this new note probably has a different title than our existing note and probably has a different body than our existing note. So we'll also want to set those. And we could either set those manually with title.text equals note.title and title.body equals note.body. That would work. Of course, again, sorry, body.text. Title and body are our XAML elements, the text boxes that we want to attach that to. However, again, if this is our note coming in as null, we don't want to do that, so we can do it like this. Alternatively, since we've already written this on note changed event handler, we could just manually invoke that event handler because it's going to do these two things as well. So if we were going to do that, we just invoke on note change by calling it directly. We need to provide the sender, which is no longer going to be this because what we actually want to spoof or pretend is sending it is our note object. And we can go ahead and create a new event args. Now this is actually a little bit cleaner of an implementation because now we are only defining how to respond to a changing note in one place in this onNoteChanged event listener. The other nice thing about this approach then is if we maybe add more detail to a note, we only have one place to come in and add those additional details, like maybe we add a priority to notes or something along those lines. Then we just have to change the field in one place here, as well as the front-end XAML, and that takes care of it. We don't have to hunt through our code for multiple places to do that. So be on the lookout for opportunities like that. When you find yourself repeating code, we always want to think, is there a better way of reusing the existing code that we already have, or potentially spinning out a new helper method to do the same thing. At this point, we have everything hooked up. We should be able to go ahead and run our program and see it work. So there is our program. We have a title across the top, which is the current time when that note was created. If we create a new note, notice that the time changes because now we have a new note object. If we type something in, and clear, that should clear out our note. Oh my, that's not working. But our mutate note is. So let's, oh, and there goes our clear. Actually, that's a good thing to take a look at. When we modify our so what we actually have right here is called a one-way data binding. So we are pulling the title and the body from the underlying note, but when we edit, we're not actually changing that underlying note because this is actually only a one-way binding. So the value of the note is coming through to the user interface, but the user interface is not actually changing the underlying value of the note. In order to do that, we have to do two-way data binding. And we'll go ahead and tackle that next. That basically means that for our note editor XAML code, we need to add event listeners to these two guys, the text box for the title, the text box for the body, that are going to update the underlying data object, the note data object, when they are changed. So let's go ahead and do that. We'll jump down into our note editor code behind. We're going to add a couple new event listeners. So the first one is for on the title changing. And for the text box, we are going to be listening for the text changed event, and it provides a text changed event args object. If you look at that object, it will tell you what the old text and the new text are, and a couple other options. But we really don't need to worry about that because we know exactly what's changing. It is the note.title, and we're going to set that equal to the title XAML elements text, or the title controls underlying text. So when we type, we'll go ahead and apply that event listener, and we'll do the same thing for the body. Okay, so we have those two event listeners. We're going to go ahead and hook those up in our note editor front end. So here in the title, the event we're listening for is text changed. We're going to assign that to on title change, and the same thing for the body. We will assign its text changed event to the on body changed. So these are now going to be making changes to the underlying note, and as you might think, that should trigger changes to the note. So let's go ahead and take a look at maybe what happens when we change that body. So I started typing, whoops, went a little too much on my typing, because the very first character, it triggers the event. We come into this event handler. If we take a look, the body.text has G, because that was the character I typed. Our note body is still the empty string. We're going to do a combination of step intos and step overs. So I'm going to step into, or step over that particular event. And there's our G. So we're going to go ahead and change where our event handler is, or sorry, our breakpoint is. If we go into our note class here, and let's go ahead and set it on the setter. So we'll see when we set that new note. So when that value comes in from hitting the R key, we have now a body of G. We're changing it to GR, and if we hit that second breakpoint, now we're in the setter. So we set that. We look at the body. Its value is G. The value coming in is GR. So we are not going to return on this line. We're going to go ahead and set the body to the new value. We're going to invoke this note changed event handler. So I want to step into that and see where that takes us. Look, it brings us to the on note changed event listener. We're going to continue stepping over now. Our note is not null. It is bound to a note, so we're going to keep going. We're going to set that title's text to the note's title. Notice these two are actually the same right now. And then we're going to set the body to the note body, and notice that those two are actually the same right now. So that brings us back, because we just stepped through that. And now the body is triggering with the on body changed, because it has just gotten that body change event. Now notice again, note and text, those are both the same. And there we go. So that is something that you need to be thinking about, is it could be very possible to set up an infinite loop where you make a change to the note notifies the user control that that change has happened, the user control updates itself, notifies the note that it's changing, and vice versa on infinite number of looping times. Now that's actually one of the reasons we put this check here, is to again make sure that if we're trying to change the body to something that already exists, we are not going to be doing that infinitely numbers of times, because once they are the same, this invocation is not made. The different WPF controls have a very similar mechanism built into those. That's why this one didn't actually continue infinitely long. But That is something, if you end up writing a completely custom control, you need to be aware of and cautious about. So once again, here's our main window. Now we can go ahead and type notes. We can create a new note. We can mutate an existing note, and we can clear a note. And that's all we have for today. So you have successfully created a two-way data binding from scratch. Congratulations to you.